Welcome to the Explainer. Today we're talking about TypeScript. You know, that thing that gives JavaScript, well, superpowers.
Okay, so let's be real. You've just spent all this time getting good at JavaScript, right? And now someone comes along and says, hey, there's this other thing you need to learn. I know it can feel a little frustrating, but trust me on this one. Stick with me, because I'm going to show you why TypeScript isn't just more homework, it's the key that unlocks your developer's superpowers. So here's what we're going to cover. First, we'll look at the problem JavaScript had that made TypeScript necessary in the first place. Then we'll unpack what a superset even is. After that, we'll dive into how its type system actually works, see it in action catching errors, and finally, tie it all together to show you why this is such a game changer.
All right, let's kick things off with part one, JavaScript's dilemma. To really get why TypeScript exists, you got to go back in time a bit and understand where JavaScript came from.
So, picture this. It's 1995. JavaScript is born. Its whole purpose in life? To do simple, little things inside a web browser. That was it. But then, fast forward to the mid-2000s, and clever developers are like, hey, we can use this for server-side stuff too. The only problem was, as the projects got bigger and bigger, it started to become painfully clear that JavaScript was being asked to do a job it was never, ever designed for.
And that led to some serious growing pains. Because JavaScript wasn't built for these massive enterprise-level applications, it was missing some key features for keeping things organized and safe. And what did that mean? Well, it meant that tiny, sneaky bugs would often only show up after the code was out in the wild, being used by real people. You can imagine how stressful and difficult that made managing huge projects.
Okay, so the stage is set. JavaScript has a problem. The solution? Enter TypeScript.
So, what is a superset? Think of it like this. TypeScript isn't a brand new language you have to learn from page one. It's more like JavaScript plus an expansion pack. It has everything JavaScript has, and then some. In fact, any valid JavaScript code you write is already valid TypeScript. You're not throwing away what you know, you're just adding a powerful new layer on top.
The real magic, the key difference, all comes down to one word, typing. See, JavaScript has what's called dynamic typing. It basically waits until your code is running to figure out what kind of data it's working with. It's flexible, sure, but it's also a perfect hiding spot for bugs. TypeScript flips the script with static typing. It checks all your data types during development before the code even gets a chance to run. This makes your code way more structured and, you guess it, a whole lot more reliable.
And don't think this is some small niche thing. Oh no, the developer community has spoken, loud and clear. Right now, a whopping 60% of JavaScript developers use TypeScript. It's not just a trend, it's pretty much become the industry standard for building serious, modern apps.
Okay, so how does it actually do all this? Well, that brings us right to our next section, how the type system works. This is really the engine behind the whole thing.
The easiest way to think about a type system is like a grammar checker, but for your data. It's just a set of rules that the language follows to make sure you're using your data correctly. You know, making sure a number is being used like a number and a piece of text is being used like text. The type system is just the referee that enforces those rules.
So here's the play-by-play of how TypeScript does its thing. It's pretty cool. First, it just scans your code and looks at the values you've set. Step 2, it uses that initial value to infer or figure out what the data type should be. Then, and this is the important part, it keeps an eye on that variable everywhere else you use it. Finally, if you ever try to do something that breaks the rule, bam, it flags an error for you right then and there, inside your code editor.
And that leads us to maybe the single biggest benefit for you, the developer. Part 4, catching errors early. This is a huge deal.
All right, let's see this in action. It's super simple. Imagine we write this line of code. Let Singer equals Alexander. That's it. Because TypeScript sees the quote marks, its type inference immediately kicks in. It just knows. It knows that this variable, Singer, is a string, and from now on, it must always be a string.
Okay, so now what happens if, maybe 100 lines of code later, we're tired, we're not paying attention, and we write something like Singer equals true? Well, in plain JavaScript, that might cause a crash way down the line. But in TypeScript, instantly. You get a little red squiggle and an error message that says something like, whoa, hold on, type boolean is not assignable to type string. And just like that, the bug is caught and squashed before it was even born.
This fundamental rule has a name, assignability. It's the heart of the type system. It's just a simple check. Can a value of this type be assigned to a variable of that type? In our case, the answer was a clear no. A Boolean value just can't be assigned to a variable that TypeScript knows is a string.
And I know it sounds simple, But this is the whole game. This one little check wipes out an entire class of bugs that are so common in JavaScript. Bugs that might otherwise slip through testing and end up crashing your app for a real user. It's like having a permanent safety net under you while you code.
Okay, let's wrap this up. Section 5, the developer's superpower. Let's talk about why this isn't just a cool techie thing, but why it genuinely matters to you.
The benefits are just massive. You're catching bugs the moment you type them, not weeks later when a user finds them. Your code just naturally becomes cleaner and more predictable. It even documents itself. You can go back and change big chunks of old code with way more confidence. Your code editor feels like it's reading your mind with smarter autocompletion. And working on a team, it's a lifesaver because everyone is on the same page about what the code is supposed to be doing.
So, I'll just leave you with this one question to think about. Now that you've seen how TypeScript acts as your copilot, giving you all this safety and clarity, doesn't writing code without it feel a little bit like you're flying blind?